Welcome everybody. In this video we are going to find the greatest common factor of monomials. And so here we are given two monomials and asked to find the greatest common factor of the two of them. And the way that we do this is we break each one down into its prime factorization. All right, so factors that are prime numbers that give us the value of the monomial. So let me show you a little bit what I'm talking about. So to break this 42 down, we're going to do a factorization tree. In 42, if we break this down, I know that factors of 42 are 2 and 21, right? 2 times 21 gives me 42. So 2 is a prime number, so I'm going to circle that because I know that we can't break that down any further. But 21 is not a prime number, so I'm going to break this down into 2 more. Well, what 2 numbers multiply to give us 21? Well, 3 does and 7. So now we have all 3 prime numbers. And this is the prime factorization of 42. So in order to get 42, you do 2 times 3 times 7. All right, and then for the variables, we break them down based on their exponent. So here we have 5 A's and 2 B's, so we are going to break this down to A times A times A times A times A, 5 of them, and then 2 B's. And here we have the prime factorization of this monomial all broken down into their individual prime factors. So if we multiplied this back out, we would get 42a to the 5th times b to the squared. We're going to do the same thing over here. So here we have 22. We're going to do 2 times 11. Hey, and I notice right away these are both prime numbers. So we don't have to break these down any further because there aren't any more factors to split these off into. So this is going to be 2 times 11. And again, we're going to break the a and the b down into however many are there for the exponent. So we have 5 a's again, 4 and 5, and this time we have 3 b's. So in order to find now the greatest common factor, we are going to multiply all the factors that these two have in common, but they has to have 1 to 1. So let me show what I'm talking about. So here we have a 2, and so we also have a 2 here. All right, so that is going to be a factor they have in common. Here is a 3, but there's no 3 here, so that one isn't. Here we have a 7, but there's no 7 over here, so cross that out. Over on this side, there's an 11, but no 11 over here, so we're not going to use that. Moving on to our variables, we have 1, 2, 3, 4, 5, so we are going to use all 5 of them because there are 5 as well over here. All right, and then looking at the b's, here we only have 2 b's, and here we have 3, but we can only go 1 to 1 with common factors. So since this one only has 2, we can only take 2 over here, and so we don't use this last one. So in order to finally find that greatest common factor, we're going to multiply the common factors together to find our greatest common factor of the two. So we're going to have 2 times A times A times A times A times A times B times B. And then that simplifies, of course, to 2a to the 5th b squared. All right, so you may have recognized that from the beginning. Greatest common factor between 42 and 22 is 2. I see I have a to the 5th and a to the 5th, and I only have b to the 2nd here, and maybe you recognized it. But this is a systematic way in order to find the greatest common factor of monomials in case you find yourself stuck, and that is your final answer.